So this section, we should have, and we already have done it before, but I'm going to quickly explain it to you again so that we remember what we're supposed to be doing, feel a little bit more confident in it, whatever we want to justify it as. But we are going to go over it again. And so we're going to review what it takes to graph using a table of values and then how we get an equation of a line from that table of values. So x-intercept, really nice and simple. Does anyone remember what it means? Okay, it's the place where our graphed line crosses the x-axis. So on my mini graph here, this is my x-axis, this is my y. My x-intercept is this place right here. So it would be -1, -2, negative whatever value is there. That is my x-intercept. Except I've literally been writing that in the wrong section. Sorry, guys. No one said anything as I'm talking about x's and it says y. That goes down there. Okay, so our y-intercept then is the x-intercept is the place where the x or the line crosses the x-axis. What's the y-intercept? Place where our graphed line crosses the what axes? So that spot right there on our graph. So it's the place where it crosses our y in our axes. Okay, our slope is the variable m, but we find it using 2 points by saying y2 minus y1 over x2 minus x1, and it is how steep the line is. Okay, so you're going to have a greater number on the top half of our fraction than our bottom half, and we're going to have a steeper line. So 2 over 1 is going to be, actually I should change those numbers up a little bit. 3 over 4 is going to have a steeper slope than 2 over 1. Okay? So that's that there. Slope-intercept form is the equation that we've been using the whole time. Okay? It is the standard form that you're going to see over and over and over again. And this is our y equals mx plus b. So your y and your x are points on a graph. On a graph or from a table of values. Table of values. Okay, so that's your y and your x. Your m, we just talked about it being our slope of the line. And our b is our y-intercept. Intercept. So slope-intercept form needs to include the slope and the y-intercept. Okay, that's why we have both of those words in our title of our equation. So what we're going to be doing in this section, and you have done it before, is making a table of values or getting a table of values, graphing it, and then potentially either writing an equation if you don't have the equation given to you, or answering what a y-intercept is, and kind of filling in the gaps of our knowledge there. So this question here says make a table of values to graph the equation 2x minus 3y equals 6. Then graph it. So what I'm going to do, the first thing I'm going to do is rearrange my equation. Okay, so I want to get it into slope-intercept form. So my original equation is 2x minus 3y equals 6, and I need to put it into y equals mx plus b. So So I'm going to need to separate my 3 and my y from each other. My 2 and my x can stay next to each other. And I'm going to need to make sure that b stays on the opposite side of the equal sign from my y. Okay, so that's what this constant value is just our b. So what I'm going to do is minus 2x from both sides. So then I'm going to have negative 3y equals negative 2x plus 6. Okay, and then I'm going to divide both sides by 3 or negative 3 here. So I'm going to be left with y equals negative 2 divided by negative 3, which is just 2/3. Whoops, that's not a 3. 2/3 x plus 6 divided by 3. So 6 divided by 3 is 2. Thank you. Okay, so this is my slope of my line equation here. Okay?
Is that not a negative 2?
The first one?
Oh.
Because that's negative 2 divided by negative 3. So that cancels out our negatives there. Okay, once my equation is put into the proper slope-intercept form, I am going to make a table of values. Okay, so we've done this before as well, but let's do it again. So a table of values has my x and my y on either side. You can draw it like this, or if you like it sideways better, that's fine too. It doesn't matter to me. What I'm going to do is start with some pretty standard x values. So you can either go 0, 1, 2, 3, 4. You can go up by 2s. You can start negative and go positive. It doesn't matter what we plug in for our x values. So I am just going to go 0, 1, 2, 3, 4. What I am going to do is, oh, actually here, this is what I should be telling you. When you have a fraction like 2/3, sometimes it's easiest to go up by your denominator. So you'd have 0, 3, 6. You could put a negative 3 in there if that's what you wanted. So sometimes having values that match your denominator, if you have a fractional slope like this, makes it easier to do the calculations. So let's plug in our x's into our x spot to solve for y. So I am going to, and you could plug it back into the original way it's written, it doesn't really matter. So I'm going to go y equals 2/3 x, which I'm going to put in as negative 3 plus 2. Okay, so this is like saying negative 3 over 1. And so I'm going to have negative 6 because I'm multiplying my tops together and I'm multiplying my bottoms together over 3 plus 2 is equal to my y. Okay, so negative 6 over 3 is what value? Negative 2. Okay, so negative 2. Oh, this should be a negative 2 here because this was, there you go. That's what I'm doing wrong. That's a negative 2, which means that's a negative 2. Okay, so 2 then, negative 2 minus 2 is what? Negative 4. Okay, so when my x is negative 3, my y is going to be negative 4. Okay, let's do that again. So my next one, y equals 2/3 0 minus 2. So anything times 0 is going to be 0. So 2/3 0 is just 0 minus 2 equals y. And so when x is 0, what is my, negative 2. Okay, let's do one more here. I'm going to plug it in for a positive 3 this time. So y equals 2/3 times by 3, which is 3 over 1, minus 2. So I'm going to get 6 over 3 minus 2. What is 6 over 3 simplified to? And so what's 6 divided by 3? 6 divided by 3. Just this part right here. What is that? Thank you, Chelsea. So 2 minus 2 is, then Junso said 0 earlier. So I'd put 0 in here. Now you could keep going, but you're going to start to realize that this is going up by 2 each time. So my next one is going to be positive 2 because this difference is the same. Okay, so if my x difference is the same, my y difference is the same. So that means if I had 9, this one would be 4. And I could keep going like that. In either direction. If you wanted to go more negative, that would work too. So I've created a table of values. The next thing that I need to do is graph it. Okay, so I'm going to look at my table of values and go, okay, I have negative x values and I have negative y values. And so I need to make sure that my graph has 4 quadrants, okay? So 4 different squares. If you don't have negatives of both, you don't need to draw everything. That's okay. But just make sure that you're paying attention to your negatives and positives there. So x at negative 3 is 1, 2, 3. And then negative 4 in the y direction is 1, 2, 3, 4. This is my first point here. My next point is x is 0. And my y is negative 2. And then my x is 1, 2, 3. And my y is 0. And then I've got 6 and 1, 2. And I can draw my line through these points here. Roughly. Obviously, that's not a perfect line. But we're just going to pretend that I did that better than I actually did. So, I'm going to confirm here. My y-intercept from my equation was negative 2. It lines up with negative 2 on the graph there, okay? And my slope was rise of 2 and over 3. So between each point, there should be 1, 2, 1, 2, 3. Okay? So that is how you would then graph from a table of values and what it means when we ask for slope-intercept form. Are there any questions?